Hello class, in this video I'll be showing you another example on how to read and analyze the graph of a function. Let's begin. Alright, so the graph of m of x is given below. Use it to answer questions G through J. And before I do that, I'm going to label the horizontal axis x and the vertical axis y, which is equal to m of x. I'm also going to place an arrow at the end of this graph to represent the fact that it travels down forever in the negative infinity direction, and it travels to the right forever in the positive infinity direction. Okay, first question. Is this graph a function? Well, you may recall that a relation is a function if every input value corresponds to one and only one output value. So what I'm going to do is I'm going to place a vertical line through the graph like such. And what does that vertical line represent? Well, the vertical line represents one input value. The graph represents the output values. And as this vertical line travels the length of this graph, notice that the graph only crosses the vertical line once. So we can conclude that every input value has one and only one output value. So this graph represents a function. All right. On to question H. What is the domain of m of x? All right, so the domain of a function is the set of all real numbers that when inputted into the function create a real number output. And if we take a look at this graph here, notice that there are going to be many different domain values. In fact, there are going to be infinitely many because this graph is a smooth, continuous line. Now, normally I would try and find a smallest value in the domain and a largest value in the domain. However, this graph doesn't have either. It doesn't have a smallest value in the domain because there is a hole at -3, 4. And there isn't a largest value in the domain because the graph travels to the right in the positive infinity direction forever. All right, so how do I write the domain as an inequality? Well, if the graph did have a smallest value in the domain, it would be at -3. And the domain values increase without bounds from there. So I'm going to write the domain as x is strictly greater than -3. And in interval notation, that's going to look like this. I'm going to start with what's supposed to be the smallest value in the domain, which is -3. But since -3 is not part of the domain, I write the parenthesis there and not the brace. And I'm going to go all the way to infinity. So there is the domain in inequality and interval notation. Okay, how about the range? The range is the set of all real number output values. All right, so just like the domain, there is no smallest value in the domain in the range, and there's no largest value in the range. So to write this as an inequality, I'm going to do the following. the largest value in the range would have been 4, and it looks like the range values just decrease without bounds to negative infinity. So I'm going to write the inequality as y is strictly less than 4. And in interval notation, I'm going to start with negative infinity, and I'm going to write a 4 there, but I'm going to put a pair of parentheses, or a parenthesis there after the 4 to represent the fact that 4 is not part of the range. So that is the range and inequality and interval notation. And finally, list any symmetry with respect to the x-axis, y-axis, and the origin. Okay, let's start with symmetry with respect to the x-axis. Now notice, I'm going to place this point right here. If there was any symmetry with respect to the x-axis, there would also be a coordinate right here on the graph. And since there is not, there's no symmetry with respect to the x-axis. All right, symmetry with respect to the y-axis. So let's do the same point. So this point is about a little more than 2 to the right of the y-axis. On the same horizontal plane, there should be a point right here, but there is not. So there is no symmetry with respect to the y-axis. Now with respect to the origin, from the origin, I'm going to travel a little bit more than 1 to the right and exactly 2 units up. So you would expect to see a point a little bit more than 1 unit to the left and 2 units down, but you do not. So we can conclude that there is no symmetry with respect to the x-axis, y-axis, or the origin. And we are done.